Hi Calculus, welcome back. Our objective today is going to be to find derivatives of implicit relations at a specific point. So we're just going to do a little bit of a continuation of our last lesson. I'm going to go ahead and pause the screen. You know what to do from here. All right, I'm going to force another pause on your screen. Can you go ahead and copy example 1, and then we're going to do this together. Okay, so we want to write the equation of the tangent line to the given graph at the point 1, 1. So we know we want point slope form. We have a point. We just need to find the slope, which will be the first derivative or the second. That'll be the first derivative. Okay, so let's come and find the first derivative. Now, question for you. If I were to ask you to find, I have lost my mouse. To find like f prime of 1, where f of x is equal to x squared minus 5x all over sine of 2x. What I'd hope you would do is do like a quotient rule. You do need some chain in there. And then instead of trying to simplify anything, as soon as you find the derivative, you would plug in 1 for x and simplify from there, right? It's a whole lot easier to simplify when you're dealing with just numbers as opposed to numbers and variables, okay? So we're going to take that same approach. We are going to do our implicit differentiation, much like our last lesson, but as soon as we're done with that first step, instead of doing all the algebra, step 2 through 4, we're going to plug in the point 1, 1 and then solve for dy dx, okay? Very similar to when we were dealing with actual functions of y in terms of x, okay? All right, so let's go here. Let's look at the left-hand side of the equation. Any special rules? We need chain rule for the left side, right? So let's just be careful there. And what about for the right side? Any special rules? For the right side, we need product. Okay, so again, just kind of strategize before jumping into these. So let's work with the left side here. You said chain. So I'm going to take the derivative of the outer. So I'm just going to fly that to hold the inside, right? Then times the derivative of the inside. Okay, so derivative of x squared is 2x. Do I need a dy dx there? Nope, because I'm differentiating an x term. And then derivative of 2y with respect to x will be 2y. Do I need a dy dx there? I do, right? I differentiated a y term with respect to x. Okay, so that's the derivative of the left side. Let's move on to the right-hand side. We said we need product rule. So think of this as 4x squared times y, okay? So we want to derive the first, so that will be 8x. Do I need a dy dx there? I do not. All right, then hold the y. Do I need a dy dx there? I do not. I'm just holding the y, okay? Product is plus, so now I'm going to hold the first, so that'll be 4x squared. And then the derivative of y will be 1. Do I need a dy dx there? I do. I'm differentiating a y term with respect to x. The variables don't match. Okay, now if we were doing this yesterday, we would have a whole lot of algebra to do here, right? But today, we are looking at a specific point. So right now, go ahead and plug in 1 for both x and y. So let's see what we get here. I get 2. I'm going to have 1 plus 1 here, so that's 2 times. Here I'm going to get 2 plus 2 dy dx. Remember, dy dx is what I'm solving for, the first derivative, right? Equals, all right, 8 times 1 is 8, plus 4 times 1 squared dy dx becomes 4 dy dx. Okay, so let's clean this up a little bit. Here we've got 4 times the quantity 2 plus 2 dy dx, and I'm just going to leave this as 8 plus 4 dy dx. We've got some options here. I think I'm going to go ahead and just divide everything by 4, divide both sides by 4. When I divide the left side, that 4 just goes away, right? And on the right side, I get 2 plus 1 dy dx, okay? Solving for dy dx, I am going to go ahead and subtract 2 from both sides and add and let's subtract dy dx from both sides as well. So if I subtract this dy dx from both sides, I get 1 dy dx, which is what I'm looking for, and then 2 minus 2 is 0. So dy dx is 0. What does it mean for the derivative to be 0? means you've got a horizontal tangent line, right? Let's take a look at Desmos, see how we did. So here is the original graph. This is called a bifolium. And we want to find the equation of the tangent line at 1, 1. And I can tell, yeah, that's going to be horizontal, right? Here, if I plug in what we got for the slope, which was 0, that looks good, right? If I zoom in, again, I do have a horizontal tangent line there. Slope is 0. As I zoom in, the purple and the green start to become 1. So that looks good. So our final answer would be, if you want to write it in this form, y minus 1 equals 0 times the quantity x minus 1, also known as y equals 1, either way. Force a pause on your screen. I'd like for you to write this and also do the first step for me. So go ahead and differentiate both sides with respect to x. All right, go ahead and check yourself. Change anything that you need to change here. And now I'd like for you to keep going. So we're going to plug in the point 8, 1 and solve for dy dx, which will give me the slope. And I already have the point, so then I can put it into point slope form. Remember that 1 to any power is 1. And just as a hint, 8 to the negative 1/3 would be 1 over 2, right? 8 to the positive 1/3 is the cube root of 8, which is 2. And then the negative is going to put that 2 in the denominator. So those are a couple hints. Go ahead and try to find dy dx on your own. And then I'm going to throw a link into Desmos for you into the next question and check with Desmos there for me, okay? All right, hopefully this is what you got. If not, go ahead and pause the screen and correct anything you need to. All right, I'm going to go ahead and force a pause on your screen. Go ahead and copy example 3 in your notes. Okay, so what's different about this one is that we're asked to find the second derivative, right? Which sometimes what comes up in a free response if we're trying to determine like if our approximation is over or under, because remember the sign of the second derivative tells you the concavity of the original function, which will tell you if your tangent line sits underneath the curve or over the curve, right? Okay, so there's a couple ways to do this. I'm going to go ahead and get dy dx by itself first, and then go ahead and find the second derivative from there. So let's try this together. Any special rules on the left-hand side? No special rules, and none on the right-hand side, right? So I've got 2y. Do you want a dy dx here? Absolutely. Plus 2x. What about a dy dx here? No. Equals 0. And again, I'm going to go ahead, we could now go for the second derivative right here if you want. Sometimes that is a better strategy. For this one, I'm going to go ahead and get dy dx by itself. So I would subtract 2x from both sides, right? And then divide by 2y. So I'm getting negative x over y for dy dx, which, by the way, at the point 1 over 2 would be negative 1 over 2, right? I'm going to kind of put that to the side here. Okay, now we need to go ahead and find the second derivative, right? So I'm going to write this down here, that dy dx is negative x over y. Now I want to find the second derivative, so I'm going to, the derivative of the left side would be the second derivative, right? Now for the right-hand side, any special rules? Any quotient here, right? But keep in mind that when you are differentiating with respect to x, so anytime you derive, remember, a y term, you need to tack on dy dx. Y is a function of x, okay? So I'm going to derive the numerator, hold the denominator, minus hold the numerator, so this is going to be plus x. I'm thinking of the numerator as negative x, by the way. And then derive the denominator, so that'll be 1 dy dx, right? All over the original denominator squared, okay? We're almost there. Now we can go ahead and plug in the point 1, 2. So I get negative 1 times 2 plus 1. Now dy dx, remember I found that earlier. That is negative 1/2 all over 2 squared, right? Cleaning this up a little bit, I have negative 1 minus 1/2 in the, I'm sorry, negative 2 minus 1/2 in the numerator, so that'll be negative 2.5, also known as negative 5 over 2, right? All over 4. And then, let me give myself more space. All right, so we have negative 5 over 2 divided by 4, which is the same as multiplying by 1/4. So I'm getting negative 5 over 8 as my final answer for the second derivative. All right, you all, that is what I have for you for today. I will see you all next time.